There's a 6 feet person. They're walking towards this 18 feet light pole, and they tell us that they're walking at a rate of 4 feet per second. So this distance right here is changing at a rate of negative 4 feet per second. But maybe we'll use that in just a bit. The problem is talking about the shadow. So here's my light at the top. Light casts a beam down here, and so the length here, that's like the big thing we want to solve for, is this x prime. We want to find out how fast that shadow is changing. So we'll call that x, and the goal is to find out the rate of change of x. So we want to know what x prime is. Okay. And so another variable in this problem, it depends on time. If this is x, then we don't know what this is unless you give us a certain instance in time. Like they tell us that we're talking about 10, we want to find out x prime when y equals 10 for this problem. But we got to keep it abstract so we can make an equation. Then we can take a derivative of that equation and help us find out what x prime is. Okay, so we got x, y, we got 18. You might be thinking Pythagorean theorem because it's a right triangle, but I don't think we're going to need in this one. What I'm seeing are two similar triangles. You've got this big triangle, which represents the entire situation. Okay, I'll draw it down here. This big triangle, this length down here is the length of our shadow plus the distance we are from the pole. Right? Remember, y is the distance the person is from the pole. And then this part is constantly 18. That's never changing. Right? That's the big triangle. And then this smaller person makes a similar triangle to that big triangle. We say it's a similar triangle because it's drawn inscribed inside the other triangle. And in this similar triangle that I'm drawing over here, oops, this distance is x, and this person is 6 feet tall. And if you know that two triangles are similar to one another, then what you can do is you can make an equation out of the ratio of the corresponding sides. And what that means is you take the bigger side of one triangle and divide it by the corresponding side of the other triangle. And that should equal the bigger side of the bigger one of the sides of the big triangle, I should be saying. One of the sides of the big triangle dividing by its corresponding side in the smaller triangle. Okay, and so that's an equation that we can use. We can take a derivative with respect to time, and this will help us find out what x prime is. But we're able to relate those two things to one another through an equation by using similar triangles. So take a ratio of one of the sides of the bigger triangle by its corresponding side in the smaller triangle, and you can set that equal to another ratio. Okay, so for this equation, 18 divided by 6 is 3. I'm going to multiply both sides by x. And to simplify it even more, I'm going to subtract x from both sides. And now, since I want to know something about x prime, the change in the shadow, I'm going to take a derivative of this equation with respect to time. I don't know what x is with respect to time. I don't know what y is with respect to time. But if I take a derivative with respect to time, using implicit differentiation, because x is not in terms of t, the time variable, and y is not in terms of t. So that's what it looks like using implicit differentiation. And they actually told us what y prime is. How fast is this distance changing? Well, we're losing distance, right? It's a negative 4 feet per second because it's getting smaller. So I can divide 2 from both sides, so I get x prime equals negative 2. That means the shadow is decreasing at, what was our units up here? 2 feet per second. Okay, as this person's walking towards here. And that should make sense because as you get closer and closer to a light source, your shadow is getting smaller and smaller. So we got the right sign on our number.